the next one, the third type of application in permutation combination. When it comes to application, very important applications of combination in geometrical figures. Applications of combination in geometrical figures is very important. So how to solve the questions of applications of geometrical figures? First of all, simply you have to select the required number of objects from the total maximum possible objects. For an example, find the number of triangles in a heptagon. In a heptagon, how many vertices, how many points are there? 7 points are there. From that, how many you have to select? You have to select minimum 3, because with minimum 3 points only we can make a one triangle. So with 3 points, if one triangle is possible, then from 7 points, how many triangles possible? 7c3. Sorry, excuse me. So the first one answer remains as 7c3, because the number of triangles in heptagon is given as 7c3, which is nothing but 7 factorial, 3 factorial into 4 factorial, which will give you 35. Second one, find the number of diagonals in an octagon. What do you mean by diagonals in octagon? Now, diagonals cannot be calculated directly for any figure. Diagonals can be calculated equal to total straight lines minus number of sides. What are the total straight lines in octagon? To form one straight line, we need 2 points. To make one straight line, we need 2 points. In octagon, there are 8 points. 8c2 will give you the total number of straight lines. These straight lines includes the diagonals also, sides also. And how many sides we have in octagon? We have 8 sides. So 8c2 minus 8 will be equal to the number of diagonals in octagon. Anyone give me the answer for the third and fourth question? What is the answer for the third question? Find the number of straight lines in a pentagon. What is the answer, guys, for the third one? What happened? Anyone please respond, guys. What is the answer for third one? Number of straight lines in a pentagon.
Sir, will it come like this, sir? 5C1?
No, 5c2 straight lines. We have to make a straight line using minimum 2 points, right? So you need 2 points and they are given 5 points. That's our 5c2.
Okay.
What would be the answer to the fourth one? Number of diagonals in a decagon. Just now I told you the concept of diagonals. How to find diagonals? Just now I told you. Now first find the total straight lines. Total straight lines given as a decagon is a 10c2. From that subtract the number of sides. How many sides in a decagon? 10 sides in a decagon. Is that clear to everyone? The concept of applications of geometrical figures.
Yes, sir.
Next, the concept of handshakes. Handshakes are of two types. One is fixed positions, another is random. What do you mean by fixed positions? Where people are sitting in fixed position and people not able to move. So if they are sitting, they can give the handshake only to the consecutive, the neighbors only. They cannot give to each and every one person. But random means when people are moving, so they are movable and they can give handshake to anyone. So in fixed, the number of handshakes will be n number of handshakes for n people. If there are 10 people, 10 handshakes. But for random, the number of handshakes will be NC2. N depends on the number of people. Find the number of handshakes among 50 people in a party if each person shakes their hand with every other person. What is the answer for this? Till the answer.
Will it come like 50 C2, sir?
That's all over. Just remember random means your answer is NC2. Fixed not moving means answer is N. So 50 C2 will be your answer. That's all. Similarly, second question, 10 people are there. They are shaking hands together. How many handshakes are possible if they are in no pair of cyclic sequence? Is the question is movable or not movable? And the people are fixed or moving.
Moving, sir.
So your answer will be moving means 10 C2, right? Moving means 10 C2.
Okay.
Okay. So
Yes, sir.
if they tell you that they are in a pair of cyclic sequence, the people are in a around circular way. So that means they are not movable. They can give only handshake to the neighbors only. So then the answer becomes only 10. But as it is mentioned, no pair of cyclic sequence, that means they are not in a cycle, so they are moving. So if they are in a pair of cyclic sequence, then it will be only 10. Next concept. The very easy one, in how many ways a leap year will have 53 Sundays? Tell me how many weeks we have in a year? How many complete weeks we have in a year? How many completed weeks we have in a year? Let it be leap year or a non-leap year. Complete weeks, how many weeks are there? Divide 365 by 7, you will get the complete weeks. How many completed weeks you have? We have 52 completed weeks, 52, which is nothing but equivalent to 364 days. 52 completed weeks is equivalent to 364 days. That means in every non-leap year, we have 1 day extra. In leap year, we have 2 days extra. In every non-leap year, we have 1 day extra because we have 365 days. In the 364 days is equivalent to 52 completed weeks. Similarly, in every leap year, we have 366 days. That means we have 2 days extra other than the completed weeks. So whenever the question comes, in how many ways a leap year have 53 Sundays? Let it be 53 Sunday, Monday, Tuesday. If they ask you 53 any day, 53 any day, and in a leap year, your answer is it is only possible in a two ways only. It is only possible 2 ways. But in a non-leap year, 53 any day. It's possible only in one way. I repeat, 53 any day in a leap year possible 2 times. 53 any day in a non-leap year possible 1 time. One more different type of application in PNC. Meg and Bob are among 5 participants in a race. So there are 5 people in a race, out of which there are 2 people known as Meg and Bob. In how many different possible orders? Different possible order means in how many different 5 positions they will be arranged. So that the condition is given like that, so that Meg always finishes ahead of Bob. So Meg should be always in a better position comparing to only Bob. So they have restricted the positions of Bob because Bob position depends on Meg. Is it clear? Meg position does not depend on anyone else, but Bob position depends on Meg. If I consider that Meg is in the first position, out of the 4 positions, Bob can take any one position. If I consider Meg in the first position, then out of the remaining 4 positions, Bob can take any one position. So that means Bob have 4 possibilities. Bob have 4 positions to take out of any one. But for example, if Bob is taking this position, then the remaining 3 can be arranged in remaining 3 people in 3 different positions as 3 factorial. Because the remaining 3 people can be shuffled also. As I have fixed Meg in first position, Bob any one position out of the 4. So Bob have 4 possibilities, but the remaining 3 people can be shuffled among themselves in 3 positions in 3 factorial ways. That is nothing but 24. If I consider that Meg in the second position, and then Bob can take any one portion out of the 3 only, because Bob cannot be in the first. Bob can take any one out of 3, and the remaining 3 people 3 factorial. If I consider Meg in the third position, then Bob have only 2 positions left, and the remaining 3 factorial 12. If I consider Meg in the fourth position, then Bob have only 1 position, that is the 5th position, and the remaining 3 people 3 factorial. Meg cannot come to the 5th position because Bob has to be after Meg only. So the total number of ways are 60 ways. So in 60 ways, these 5 people can be arranged in 5 different positions, depending on the condition that Meg should finish ahead of Bob. Now, if this type of question comes in your exam with 7 people, from A to G, and the condition given like A should be ahead of C, but before B. So like this, if the condition of 3 people and totally there are 7 people, it will be very difficult to solve. For that, there is a shortcut. In this question, the total people, 5 people, 5 factorial. Question depending on position of how many people, depending on 2 people, divide by 2 factorial, that is a shortcut. For 7 people, 7 factorial. Question depends on 3 people position, divide by 3 factorial. So like this shortcut will help you to save time in such type of questions. All of you understood so far? I have completed each and everything in permutation combination except one thing, that is selection of playing cards. Playing cards, I left it off because I told you that I'll discuss playing cards in probability class. So now we are done with PHC. We'll start with probability.
Sir, can you explain this question one more time, sir?
Okay. See, the condition given that out of the 5 people, these 5 people should be arranged in 5 different positions after finishing the race. But the condition is that Meg should always finish ahead of Bob. So that is not going to happen in only one way, because Meg can take any one position. Meg can be the first, second, third, fourth. Meg cannot go to 5th position. Meg can occupy any one position out of first, second, third, fourth. That means there are 4 ways of solving this problem. First way, if you consider make in the first position, there are remaining 4 positions left. Out of the 4 positions, any one position Bob can take. So Bob have 4 possibilities. But out of the 5, Meg and Bob are fixed in 2 positions, but the remaining 3 people can be shuffled in 3 positions in 3 factorial ways. So both should happen. For Bob, I have 4 positions. For remaining 3 people, I have 3 factorial. So 4 into 3 factorial, there are 24 ways where Meg can come in the first position. Bob can come any one out of the remaining 4. If Meg comes in the second position, then Bob have only one position left out of 3, that is third, fourth, and fifth. So out of third, fourth, and fifth, out of 3 positions, Bob can take any one position. So I have taken 3 multiplied 3 factorial because 3 factorial for the remaining 3 people who can be shuffled. Third possibility. If Meg comes in the third position, then Bob can take any one position out of the last 2, either fourth or fifth. So Bob have only 2 positions left. And the remaining 3 people, 3 factorial. Fourth one. If Meg comes in the fourth position, then Bob left with only one position, that is the fifth one. And the remaining 3 factorial. So all the possibilities are possible in this situation. So everything is added is 60. But if you come down to shortcut, just take n people. N means total how many people? And 5 people. So 5 factorial divided by the question depending on the position of how many people? 2 people. Divide by 2 factorial. If the question depends on 3 people position, you divide 5 factorial upon 3 factorial, like that. Is that clear?
Yes, sir.
Another most important topic after permutation combination is probability. Probability, the number of concepts are very, very less. One thing you make sure that maximum possible questions from probability, you have to prepare very less. Because the question mostly comes from the applications of probability, playing cards. These two are the major one where you might have probability questions. Applications of probability and playing cards concept. Long back ago in school days, you studied the concept of coin. When 2 coins are tossed, 3 coins are tossed, such type of questions. So this thing was removed from the syllabus long back, 5 to 6 years back itself. Nowadays, they're not preferring asking questions from concept of coins. Similarly, dice is also another one topic which you have done in school days. It's not been removed, but yes, at least for just knowledge, you can prepare the concept of dice. Probability basically, so what are the possible samples, possible outcomes you can say in any type of question out of total outcomes. So here the most important one is applications. Very, very important is application, then playing cards. Let's have a little bit concept of dice. In dice, there are 3 types. First one, fixed sum, variable sum, and third one, multiple. How many possibilities will be there when 2 dice are rolled? How many possibilities will be there when 2 dice are rolled? Anyone? How many possibilities are there when 2 dice are rolled? What happened, guys? You studied these things in school days, right? Why no one is answering? Guys, dice. Total how many possibilities in two dice? How many pairs you will get in two dice? Very good. What happened to Batchword today? Why no one is responding in the session? 36. Perfect. So out of the 36, it takes lot of time, first of all, to figure out the condition, whatever given in the question. What do you mean by fixed sum, variable sum, and multiple? I'll give you two examples for each. Okay. Before finding the answer, let me give you two examples for each. What do you understand by fixed sum? Probability when two dice are rolled, sum is exactly equal to 8. Probability sum exactly equal to 6. Okay. Probability sum greater than equal to 8. Probability sum less than equal to 6. Probability the sum of two numbers divisible by 3. Probability the sum of two numbers divisible by 4 or 6. These type of questions are called fixed sum, variable sum, and multiple. So these three concepts you will get in exams. These are the three types of concepts in dice. But what is the problem is that it is easily solvable, but actually it's a time taking one. It's a time taking concept, but we can do it. Uh, any one of you, please kindly just complete these questions. Then I'll tell you the shortcut. Can you tell me what is the answer of probability of sum of two numbers equal to 8 when two dice are rolled?
Sir, can you repeat once again, sir?
Can you repeat the?
No, once again, can you repeat, sir? I didn't get you.
See, three type of questions are there in dice. Three types of concepts. The question based on fixed sum, variable sum, and multiple. You have already done it school days. What will be the answer when two dice are rolled and sum of the two numbers in the two dice you will get exactly equal to 8? How many such possibilities are there? I'll tell you one possibility. If I get 4 on one dice and another 4 on another dice, so if both are 4 and 4, that is nothing but sum equal to 8. Like this, tell me the other possibilities whose sum makes 8. Five by 36, Lokesh. Let us check Lokesh. 5 by 36, how it is 5 by 36? So the pairs are 4, 4, 2, 6, 6, 2, 3, 5, 5, 3. So answer is 5 by 36. Similarly, what is the answer for sum equal to exactly equal to 6? Sum exactly equal to 6. Again, for exactly equal to 6, what is the answer? You will get 1, 5, 5, 1, 2, 4, 4, 2, 3, 3. So it is nothing but 5 by 36. 1, 5, 5, 1, 2, 4, 4, 2, 3, 3. Now tell me for variable probability sum greater than equal to 8. Sum should be at least 8 and also greater than 8. So what is the probability in two dice where sum is greater than equal to 8? Please count and tell me sum greater than equal to 8. So you can see clearly how much time we are taking to calculate such type of questions. Anyone tell me greater than equal to 8. So it is greater than equal to 8. You will have 4, 4, 2, 6, 6, 2, 3, 5, 5, 3, 4, 5, 5, 4. 6, 3, 3, 6, 4, 6, 5, 5, 6, 4, 5, 6, 6, 5, 6, 6. So count now how many we got for sum greater than equal to 8. We have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So totally 15 outcomes for a greater than equal to 8. 15 by 36. Similarly, sum less than equal to 6. For that also you will get the same answer as 15 by 36. Probability sum divided by 3. What are the sum which is divided by 3? You have 1, 2, 2, 1, 3, 3, 2, 4, 4, 2. Because these sums you can see it is a multiple of 3. Next you will have 4, 5, 5, 4, 3, 6, 6, 3, 6, 6, 5, 1, 1, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Your answer is 12 by 36. Sum divisible by either 4 or 6. So either 4 or 6 you will get answers as 1, 3, 3, 1, 2, 2, 3, 5, 5, 3, 4, 4, 2, 6, 6, 2. 3, 3 is also divisible by sum of 6, 6, 6. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anything else? You have 2, 4, 4, 2 also. 5, 1, 1, 5. Totally 14 by 36. So this takes very lengthy and lot of time taken for such type of questions. Now let me tell you how to solve similar type of concepts using one of the best shortcut which I've developed almost like 8 years back. I had developed the shortcut when no need to write the possibilities. We can directly go for the answers. Okay. Please listen now. The shortcut for dice. So I told you there are three types of questions. One is let us take in fixed sum. Probability sum equal to 8. Second, probability sum equal to 6. I'll take one more question. Probability sum equal to 9. Now how to do this question? See, first of all, what is this diagram? I'll tell you. The numbers which are written in black color, they are the questions. Because in any two dice, the minimum sum you will get 2, maximum you get 12. So I have written all the questions from 2 to 12. The written with blue color ink, the numbers written blue color ink, it is nothing but they are the possible outcomes from a single dice. In single dice, what are the numbers? From 1 to 6. And I've written in the reverse order from 6 to 1. For example, probability sum equal to 8. Which number you can see below 8? Which number you can see below 8? Come on guys, batch 1, what happened to you today?
Sir, 5, sir.
That's all. Simply you write the answer as 5 by 36. What is the number you can see below 6? Again 5 by
5,
36.
sir. Yes, sir.
Sum equal to 9.
4, sir.
4 by 36. If the question comes sum equal to 11, what is the answer?
2 by 36, sir.
That's all done. Understood? Is this concept useful or not?
Yes, sir.
So please respond. I'll tell you more shortcuts. If you don't respond, I won't tell.
Yes,
Next
sir.
concept. I'll take the next concept as variable sum. Fixed sum, you got it. How to do? Variable sum. Let me take a question probability sum greater than equal to 8. Greater than equal to 8 means start with 8 till 12. Start with 8 till 12. Okay. Add all the numbers which are in blue color ink. What is the answer? From 8 to 12, add all the numbers which are in blue color ink.
10, sir. 10 by 36, sir.
Start with 8. Because they told to include 8. Minimum 8,
15 by
maximum.
36.
How much?
15 by 36.
That's all. 15 by 36. Similarly, what will be the answer? Probability sum less than 6. Less than 6 means not including 6. Less than 6, where we have to start from 5. Okay. Sorry, I have given a wrong symbol. Less than 6 means you have to, maximum value you have to take 5. Minimum 2. So from 5 to 2, what is the sum of the blue color numbers?
7, sir. 7.
From 5 to 2. That is 4, 3, 2, 1. You have to start counting from 5 till the last.
Okay, sir.
Sum should be greater than 7 but less than 11. What does it means? Greater than 7, less than 11 means which sum you have to consider? Greater than 7, less than 11. Which numbers you have to consider? Which numbers are, what are the numbers you will have greater than 7 and less than 11?
Sir, 5, 4, 3, sir.
That's all. So what is the sum?
12, sir. 12
12 by 36. Understood variable sum also?
Yes, sir.
Useful or not? Is it better than the normal method?
Yes, sir.
Come to the last one, that is multiple. Probability sum divisible by 3. Now tell me in a table of 3, what are the multiples of 3 which are possible from 2 to 12? What are the multiples of 3 which are possible only from 2 to 12? What are the multiples of 3 from between 2 from 2 till 12? Which numbers are multiple of 3? Which is the first multiple of 3?
3, 2, sir. 6, sir.
First multiple is 3 itself, right?
Okay.
Okay, so what number you can see in the diagram below 3?
2, sir.
What is the next multiple? So write 2 here. What is the next multiple of 3? What guys? What is this? No one is responding for multiples of 3 also. Everyone is simply listening to the classes. It is better than I'll take the normal class. Why I should tell you all these shortcuts?
6 and 9, sir.
So what numbers you can see below 6 and below 9? For
5 and
6, it is 5. For 9, it is 4. The next multiple after 9?
12.
So you add everything and that will give you the sum of divisible by 3. That is nothing but 12 by 36. Now you tell me probability sum divisible by 4 or 6. Which are the multiples of 4 in the diagram?
4, 8, 12.
And so add all the numbers of 4, 8, 12. What is the answer you got? 4, 8,
24,
12.
sir.
How much?
24, sir.
How come? Don't add 4, 8, 12. Add the blue color numbers. Blue color numbers are the answers. Black color numbers are the questions.
9.
You have got 9. Now, what is the divisible multiples of 6 now?
6 and 12.
6 and 12. Don't consider 12 because already we have considered 12 in the 4 itself. So only find what is the answer for 6.
5.
So what is the final answer now? 14 by 36. All of you understood the dice concept? When telling you I'm everything in shortcuts, but I'm asking what is the multiples of 3, then also people are not responding. That's what I thought. It's better to explain the normal method. Anyhow, you won't respond. Take the screenshot of these questions. You do it yourself. These are the questions of dice concept. 7 questions will be there. Take the screenshot of first 4. Completed. The next
Yes, sir.
3. The next 3. These are all the questions of dice. I need the answers tomorrow session. All the 7 questions. Done.
Yes, sir.
What is the next concept after dice?
Playing card.
The most important concept in probability is playing cards. Now we have to discuss playing cards questions, both of permutation combination also and probability also. But before that, tell me, is there anyone in the class who have not even a single idea about the cards? Like what are the different names of the cards? Or you have the basics? Anyone in the class who don't know anything about the playing cards? Because if you don't know anything about the playing cards, then I need to explain you from the starting. At least raise your hands in your, you can see there is an option called raising your hands. So I can understand if there are some people, then I'll start from the basics of explaining the playing cards. Okay, Prasad Ranganathan. Don't know anything about the cards. Only one person. Okay. Then let me explain you playing cards from the initial thing. Just give me 1 minute. I need to draw the diagram. Then only I'll explain to you each one by one. Listen carefully, guys. Totally, there are 52 playing cards. In this 52 playing cards, a deck of card means 52 playing cards. These 52 playing cards, based on the color, divided into two types. Red color cards are 26 and black color cards are 26. I repeat, the 52 playing cards are divided into two types. Red color cards are 26 and black color cards are 26. Now, in this red color cards of 26, this 26 again divided into two types based on the suit. Suit is a card of made of different shapes. Suit is nothing but made up of different shapes. So how many shapes are there? There are four shapes are there. The first shape of red color is diamond. Red is divided into two types. One is diamond shaped card, another is heart shaped card. So equally divided, 26 cards as each 13. Diamond shaped card are 13s and heart shaped card is 13s. Similarly, black is also divided into two types. Spade of 13, club of 13. So remember that spade and club are always black color. Diamond and heart are always red color. Now, this 13, 13, 13. These are called suits. So how many suits? There are four suits. There are four suits. In one suit, there are 13 cards. What are the 13 cards? The numbers are printed from 2 to 12. Sorry, 2 to 10. The numbers are printed from 2 to 10. So how many number cards? Number cards are 9. Number cards are 9. There are 9 number cards, that is from 2 to 10. What are the remaining 4? The card number 1 is called as ace, which is not written as number 1. It is printed as ace. ACE is known as the first card. The 11th card is jack, 12th card is queen, 13th card is king. So these are the 13. So in this, 4 cards are not printed with numbers. What are the 4 cards which are not printed with numbers? Card 1 is known as ace, 11 jack, 12 queen, 13 king. In between from 2 to 10, they're printed as numbers from 2 to 10, which are called number cards. These 4 cards, ace, jack, queen, king, are called as honors. Honors. Honors means the most valued cards. There are 4 honors in one suit. In total, all 4 suits, there are totally 16 honors. I repeat, there are totally 16 honors because in each suit there are 4 cards, in total 16. So 8 black, 8 red. Out of the honor, if I remove the face card, the remaining 3, jack, queen, king, which are given with pictures. Jack, queen, king are given with pictures. That is why it is called as face cards. So how many face cards? We have 3 face cards in one suit, that is jack, queen, king. So there are totally 4 suits, 3 into 4, 12 face cards. Each and every card, let it be a honor, let it be a number, are of 4 types. One of diamond, one of heart, one of spade, one of club. Please everyone respond if you have any doubt. Anyone want me to repeat? Please raise your hands. I will wait for 2 minutes.
No doubt, sir.
Others, anyone, if you have any doubt, please raise your hands. Else, I'll wait for 2 minutes, then I'll continue with the questions. Tanush, tell me what happened, what doubt you have. Tanush, which part you want me to repeat? Tanush, do you want me to repeat anything? So can I go to the questions now? Honor part. Honors nothing but honors are the most valued cards. Which are the honor cards? Card number 1, 11, 12, 13. So these 1, 11, 12, 13 are not printed as numbers. They're printed as 1 as ace, ACE, 11 as jack, 12 as queen, 13 as king. So these four cards are called as honor cards. Total how many honor cards? In one suit, that means in diamond there are 4 honor. In spade we have 4. In club we have 4. In heart we have 4. Totally 16 honor cards, which are divided 8 of black, 8 of red. In this honor, if I remove the face card, so remaining are jack, queen, king, which are called as face cards, which are 3 in one suit. Total it makes 12. Is it clear? Tanuj, is it clear now? Shall we go with the questions part now? Okay, done. See how the questions will be given in probability. Please listen carefully. Guys, is the PPT visible now?
Yes, sir.
Okay. First of all, before going to the question, please listen. What is the difference of probability questions in permutation combination and what is the difference in probability? Please listen. Any question given, if it is given as in how many ways a card can be picked, in how many ways a card can be picked, that is a question of permutation combination. But if the question is what is the probability of picking the card, it becomes probability question. Is it clear? Difference between the questions of PNC and probability of playing cards. Is that clear or not? Probability, it will be given as what is the probability. But in PNC, it will be given as how many ways you can pick a card. Because the answers are different. That is what I'm telling you. Most of the students get confused with the questions based on playing cards in permutation, combination, and probability. And they give wrong answers only because of the understanding the question in wrong way. Can you differentiate the questions of PNC and probability now?
Yes, sir.
Okay. Now, for all the questions, I'll tell you the answers of permutation, combination, also probability. I'll tell you both answers. Okay. First question, one card is drawn at random from a pack of 52 cards. What is the probability the card drawn is a face card? If this question is asked in PNC, your answer will be total how many face cards are we have? Face cards meaning Jack, Queen, King. So 3 cards in one suit, in total 12 cards. Your answer is 12. C. How many asking? They are asking to select one. 12C1 will be your answer, but this is the answer for permutation combination. For probability, your answer is 12C1 divided by 52C1 because probability means possible outcomes divided by total outcomes. So out of total of 52, you're selecting one card, and what is possibility? You have to select that one card out of the 12. Everyone understood the difference between PNC and probability? First question clear or not?
Yes, sir. Yes, sir.
Second question. One card is drawn at random from a pack of 52 cards. What is the probability the card drawn is a queen of a club or king of a heart? You know what is club? Club is one type of suit in black color. In that club, how many cards are there? 13 cards are there. One card of 2. So everything will be only 1 1 1. Queen is card number 12. How many queens are there in club? Only one queen. Because there are totally 4 queens. One queen will be from club, one from heart, one from diamond, one from spade. So all queens are only 4. In club, how many we have? We have only 4. Or means plus. Or means plus. So what is the answer for this queen of club? You have only one card, from that you have to pick one. Plus. King of heart, how much? How many hearts? 13 hearts. Out of that king, how much? Obviously 1. So 1C1. This is the answer for permutation combination. For the same question, probability 1C1 plus 1C1 divided by 52C1. Why I am taking 52C1? Because they are asking to select only one card, and it is either or. Either you pick a card of queen of club or king of heart. They are asking only for one card. If they tell you to select 2 cards, one from queen of club, another from king of heart, then 1C1 multiplied by 1C1 divided by 52C2. I repeat, if they ask you to select 2 cards, each of 1 1, then instead of addition, it will be multiplication. 1C1 multiplied with 1C1 divided by 52C2. Third question. Again, select one card from a pack of 52 cards. What is the probability? The card is either a red card. How many red cards? 26 red cards. From that, select one. Again, or. Or means plus. King. How many kings are there? Totally 4 kings are there. And out of the 4 kings, already 2 kings are included in the 26 red cards. Which are the 2 kings included in red? One king of heart, one king of diamond are already included in the 26. I cannot count it for again repeat. I can't repeat for again. So remaining how many kings? 2 kings of black, one of spade, one of club. So 2C1 divided by 52C1. All of you understood these 3 questions?
Yes, sir.
Try yourself 4th question. Tell me the answer of 4th question. What happened? What is the answer?
Will it come like 13C1, 13C?
13C1 for spade, correct?
Yes, sir.
13C1 for spade. But in that spade, out of 13, already 110 is included. Remaining how many tens? 3 tens. So 3C1. This is the answer for permutation combination. For probability, just to divide the same answer by 52 C1. 13C1 for spade. In that, already 110 has been included. How many tens remaining now? 110 of heart, 110 of club, 110 of diamond. So remaining 3 tens, that is 3C1. Whole divided 52 C1, this becomes into probability. Next question. From a pack of 52 playing cards, 2 cards are drawn at random. What is the probability both are kings? How many kings? 4. From that, select 2. This is the answer of permutation combination. 4C2 is the answer of PNC. When you divide this by 52C2, it becomes probability. Next, from a pack of 52 playing cards, 2 cards are drawn. What is the probability? One is spade and one is heart. So we want end. One is spade. From spade you select one, and from heart you select one. This is the answer of permutation combination. Now divide it by 52C2, it becomes probability. Please tell me guys if you have any doubts in playing cards concept. Any doubts in the playing cards concept?
No, sir.
Okay. Guys, do you remember how do we solve the questions of selection of balls in permutation combination? I told the selection of balls concept.
Yes, sir.
Okay, same type of problem will be asked in selection of objects in probability. Same type of questions. I'll show you. I'll just give you an idea. A bag contains 6 black and 8 white balls. One ball is drawn at random. What is the probability the ball is white? Now don't consider this question as probability. You solve the problem as PNC. They're asking that there are 2 category of ball, 6 of black, 8 of white. We have to pick one ball. It has to be a white only. How many white balls are there? We have 6 white balls. From that we pick one. So this is done. This is permutation combination. Is it clear now? Permutation combination means you have to pick the possible ball. I have to pick one ball out of, sorry, white 8, 8C1. This is PNC. Now when I have to change the problem into probability, I divide it by 14C1, that is out of 14 select one. Same concept, right? Here, second question. There are 6 white and 4 black. 2 balls are drawn at random. What is the probability that both are of same color? If both are of same color means either I should select 2 white or I should select 2 black. If I want 2 white, it becomes 62. If I want 2 white, it is 62. If I want 2 black, 4C2. So either 2 white or 2 blacks. That means or means plus. This is PNC. I should select of 2 of same color, either 2 white or 2 black. How to convert it to probability? Divided by 10C2. Third question. There are 5 white, 4 black, 3 red. 3 balls are drawn at random. What is the probability they are not of same color? What do you understand by they are not of same color? It can be all 3 different colors. But it also possible that you can select 2 balls of one color, third ball of different color. Because if I select 2 different colors, that is also all are not of same color. But there will be a lot of cases. Many cases will happen for such type of problem. You can select 2 white, 1 black, 2 black, 1 red, 2 red, 1 black, 2 red, 1 white, and all 3 1 1. So many cases will happen. To avoid that, convert the problem into shortcut. What is the probability they are not of same color can also be calculated 1 minus probability all of same color. Can also be calculated 1 minus probability all same color. Because 1 is the highest value in probability. So 1 minus probability of all same color. All same color means 3 balls of white color that can be done as 5C3 or 3 of black color that is 4C3 or 3 of red colors that is 3C3. This answer divided by total balls that is 12C3 and this should be subtracted from 1. Then this will be converted into all of not of same color. I repeat, to calculate all not of same color, we cannot do in the normal way. There will be lot of multiple cases. So prefer shortcut. The shortcut will be 1 minus probability of all same color. All same color means 3 white or 3 black or 3 red. So 1 minus 5C3 plus 4C3 plus CC3 upon 12C3. Fourth one, a bag contains 4 white, 5 red, 6 blue. 3 balls are drawn at random. What is the probability? All of them are red. So only 3 balls to be selected, that of red color. How many red? 5C3 divided by totally 15C3. There are only 3 possibilities. We have to select 3 balls out of red color. So 5C3 divided by 15C3. Anyone, any doubt in these 4 questions, please tell me.
No doubt, sir.
Next, a bag contains 2 red, 3 green, 2 blue. 2 balls are drawn at random. What is the probability? None of them are blue. None of them are blue means you don't want a blue color. If you don't want a blue color, then you should select 2 balls from the combination of red and green. That is nothing but 5C2. From that 5 balls, in this 5, it includes 2 red and 3 green. From that, select 2 balls so that you will not get any ball of blue color. Out of totally 7C2. Next one, a bag contains 6 white and 4 red. 3 balls are drawn at random. What is the probability? 1 is red and 2 are white. You want 1 ball of red color, that is 4C1, and 2 of white color, that is 6C2, whole divided by 10C3. So they are asking for 1 of white that can be done in 4C1 and 2 of red, that is 4C2. Sorry, 2 of white and 1 of red, 4C1 into 6C2 whole divided by 10C3. Next question, a bag contains of 4 red, 5 green, 6 white, 1 ball is drawn at random. What is the probability that either the ball is red color or it is a green color? We want only 1 ball, either red. From red, select 1 or select 1 from green. Whole divided by 15C1 because totally there are 15. 4C1 plus 5C1 whole divided by 15C1. Balls concept clear, guys? Exactly the same thing what we done in the previously PNC. Only there are few changes like the total possibilities should be considered in probability. All of you understood?
Yes, sir.
Okay, the last topic in probability is applications. I'm giving you some questions to you. Please try to do by yourself, and whichever you can do, do it. Rest I will discuss in the next session. Please take down the screenshot of the questions. There are only 5 or 6 questions of applications. Take the screenshot of first question. Please do it fast. Completed first question. Second question. Third. Fourth. Fifth. Sixth. The last, seventh one. We'll continue these questions. Try to do some of the question by yourself, else we'll discuss in the next session. We'll see in the next session, guys, tomorrow. Thank you. Bye-bye.
Thank you, sir.